Well, this video is for common and natural logarithms. We're going to be looking at some basic formulas here just as an introduction to these problems. So our first one is pH scale. And what we're going to be doing is finding the pH based on the hydrogen ion concentration. So it's going to be given to us right here. And we're going to take this and plug it into our formula. It will then tell us the pH. And if it's less than 7, it's acidic. It's more than 7, it's basic. All right, so let's try one. So our pH here would just be negative log. And then our hydrogen ion concentration, that's this right here. So all you have to do is plug that in. Plug this into our calculator and it'll tell us our pH. So we take out our calculator and we do negative log, and everything's going to be inputted all at once. Don't do it in parts. 0.32 times 10 to the power of negative 8. That's exactly what we have. Close the parenthesis and then hit enter. And we get 7.91. So if you look at our scale here, 7.91 would be right about here. That's a 7.91, which makes it basic. So since 7.91 is greater than 7, we know that it is basic. All right, what if we want to do this in reverse? So we know the pH scale, we want to find the hydrogen ion concentration. Well, then we just work on it in reverse. So we take our formula, which is pH equals negative log, and then H plus. And we're looking for H plus in this case. So we put 8.3 here. And then we solve our equation. So we always want to solve for the logarithm first, which means we want to make sure it's just a logarithm. So if we would divide both sides by a negative, we end up with negative 8.3 equals log H plus. You always want to divide by whatever is in front of that logarithm first, in this case a negative 1. All right, so now we just do our rewriting of our logarithm. So base here is 10. So if we rewrite this logarithm, our base is 10. And then again, whatever is on the log is equal to is the exponent. So logs equal the exponents. So it's negative 8.3. And so that would be equal to our H plus. So now if we take our calculator again and we plug that in, so it's 10 exponent negative 8.3. We end up with that. And so what does that give us? It's 5 times 10 to the negative 9. So 5.01 times 10 to the negative 9. There it is in scientific notation. And just to check it, if we plug it back in, you see there's the negative log 5.01 times 10 to the negative 9, and we get 8.3, which is what we had for our pH. So there's our hydrogen ion concentration. Now, it's not just for pH that we use logarithms. There's lots of applications for them. Anything that we can use that would represent a log graph. So in this case, it's the annual passenger traffic in millions for LAX approximated by the formula. So anytime we have a graph that kind of has that shape to it, right, we can do a regression on it to give us a logarithm if it fits it well. All right, so what is the likely annual passenger traffic? Right here is our formula for it in 2007. So if you look at it, you always want to find out what our T is. T is going to always be years since some year. It just makes a lot more sense. So it says where T is the number of years since 1990. All right, so if you have 2007, if we just subtract 1990, you'll see that gives us 17. So that would be our T. So whatever the years are since, that's what we plug in. So if we plug in 17, and then put 17 in there, plus 1. Again, this is just a calculator problem. So if we bring up our calculator, clear that out. If we put 58.7 plus 2.3 times, and in this case it's a natural log, so ln 2 times 17, you can put it in parentheses rather, plus 1, and hit enter, and we get 66.87. So let's do 66.9. Now, obviously, it's not going to be 66.9 people for annual passenger traffic from LAX. So it's in millions. That's what we were given. So it states right there that the passenger traffic is in millions. Okay. So what would n of 25 be? So if we do that same idea, n of 25, and we plug it in, so 58.7 plus 2.3 natural log, and now we do 2 times 25 plus 1. What does that give us, and what does it mean? So we take our calculator, and I'm going to just go back up and grab it, and this will allow me to just change the 17 to a 25 and hit enter, and so we get 67.7. So it's 67.7 million. All right, so that's the number of passengers. But obviously these are two-part questions. There's some input and output. So we plugged in 25. So if we now do it in reverse and we do 1990 plus 25, we get 2015. So what that means is in the year 2015, the approximate number of travelers was 67.7 million passengers. So when we want a verbal interpretation, we want to know what do our numbers mean? I mean, that's the whole point of an application, right? Okay, and our last part here, what we're going to do now is the reverse as well. So what if we have 75 million passengers? That's what we want to know. When will LAX hit 75 million? So we have our n of t, that is 75. And so if we set that there, 58.7, and we now solve this logarithm, it will tell us the number of passengers. So again, we want to isolate that natural log. So everything around it needs to go. So anything being added, we need to subtract away. And we end up with, so just 75 minus 58.7, and we get 16.3. And the same thing, we're still isolating this natural log, so that means we need to divide by 2.3. Just keep going, divide by 2.3. We end up with 7.08695. So why don't we do 7.087? All right, and then so now if we rewrite our natural logs are log base e. So it means our base here would be e, and again the logarithm always equals the exponent, and then that would equal 2t plus 1. So now if we solve this equation, same exact idea, we're going to subtract 1, divide by 2. So we end up with e to the 7.087 minus 1. And then we divide it by 2. And that would give us our t. So our t is equal to e to the 7.087 minus 1 all over 2. So if we plug that in our calculator, so we go second e. And instead of entering it, we can just go back up, grab it, scroll out of there, put minus 1. Hit enter, hit divide by 2, hit enter, and we get 597.63. So we'll just say 597.63, that's approximately 598. So if we take that, it's a lot of time, right? That is the number of years since 1990. So if we do 1990 now, add to it 598, what do we end up with? So 1990 plus 598. Hit enter, we get 2588. So in the year 2588, there should be 75 million passengers. See, logarithms grow really, really slow. You could see just from 2007 to 2015, right? It only went from 66.9 to 67.7. That's only 8 million, 0.8 million growth. And we're trying to get all the way up to 75. So basically, it's going to take a long time to get to 75 million. That's that slow growth. There you go.